We have computed the time it would take to cross the river. In this lesson, we will use that time in order to compute the drift dc. The drift is the displacement of the boat in the x direction, which is the distance dc in this case. In the previous lesson, we had resolved the velocity of the boat with respect to the river into its components parallel and perpendicular to the banks of the river. Since drift is measured along the x direction, we will use the velocity component of only the x direction, which is vb with respect to r cos of theta plus vr. This velocity is constant along the x direction and there is no acceleration. Now you will begin to see the benefits of resolving the vector vb, the velocity of the boat with respect to the ground, along the x and y directions. We will be able to analyze the horizontal and vertical motions of the boat independently. In the previous lesson, we had obtained the time as d over vb with respect to r sine of theta, and we obtained it by just looking at the motion along the y direction. Now, in this same amount of time, the boat would drift horizontally. Now you will be able to appreciate how solving becomes easier when the motion along each axis is independent. We had used the motion parameters along the y-axis in order to obtain the time taken for the boat to cross the river. Now we will use the same time to obtain the horizontal drift of the boat, which will be the horizontal velocity times the time, and in this case we will be working along the x-axis. The horizontal displacement of the boat along the x-axis is the horizontal velocity times the time taken. The horizontal velocity is vb with respect to r cos of theta plus vr, and the time taken is d over vb with respect to r sine of theta. So given the velocity of the boat with respect to the river and the angle at which the boat heads out in, we are able to predict the drift if we know the river current. This is how it would appear in the original vector diagram. Remember always that the drift is measured from the point D right opposite across the bank from A. The distance dc is vb with respect to r cos of theta plus vr times the time that the boat is moving, which is d over vb with respect to r sine of theta. To obtain the drift while crossing a river, we look at the x component of velocity of the boat with respect to the ground. In the absence of acceleration, we obtain the drift as the x component of velocity times the time taken to cross the river.